Okay, here we go with part 4 of Workplace Math 11, Unit 1, Rate of Change. And we're going to start with looking at writing ordered pairs. And ordered pairs are how we describe the location of a point on a graph, or a grid rather. Okay, so when you write out the coordinate pair, it looks like, whoops. It looks like, for example, 1, 5. It could look like that. It's always in brackets and it always has a comma between the two. When you write out the coordinates of a point, you always write the left-right number first, which is x, the x value, so the back and the side to side, and then you write the up and down number, the y value. And then you put brackets around the two numbers, separated by a comma. So that's where we get the 1, 5. And we are asked to do the coordinates of write the ordered pair or the coordinates for each item. So the pineapple is at the intersection of 5 to the right, sorry, and 2 up. So the pineapple is at 5, 2. And the onion is here at 1, 2, 3, 4, 5, 6, 7, 8, and 1. So that's at 8, 1. Oh, sorry, my cat has come to visit. And I'm going to do these two next. What is at 2, 2? So we go to the right 2 and up 2, and that's a tomato. And at 9, 7, 9 and up 7 is a lemon. And I'm going to suggest that you pause the video there, do the next couple, and then just come back and check them, okay? Okay, there you can see the rest of the results of this. I'm not sure what number 10 is supposed to be. Is it a plum? It's it's this one here. Okay, I'm not sure if that's a plum or what it is. Okay, pause the video, go do the practice questions, and I'll meet you back here in a minute. Okay, now we're going to talk about positive and negative slopes. If a line on a graph rises from left to right, that is, it goes up if you move your finger along the line. So that's like this, it's going up. The slope is positive. If a graph drops or goes down from left to right, it goes down if you move your finger along the line, like here. This is going down as we go right to left. The slope is negative. Because the rise is negative. So we talk about the slope as rise over run, and the rise in that case is negative. Do the practice, come on back. Okay, just a reminder that you should be checking your answers when you do the practice. It's really important you do that. You don't want to be practicing things wrong. Okay? All right, using rise and run to calculate slope from a graph. Is the slope positive or negative on this graph? Well, it's positive because it goes up. It's positive. And calculate the slope as a fraction and a decimal. So the slope is m equals rise over run. And starting here, it goes 1, 2, 3, 4, 5 is our rise. That's how far up it goes. And our run, do that in a different color, 1, 2, 3 is how far to the side, to the right it goes. Okay, so that's our slope as a fraction, and as a decimal, you just put that into your calculator and you go 5 divided by 3, and that gets you 1.6 repeating, which we round to 1.67. All right, so the steps to follow are you draw a triangle, which I didn't do, so I'll do that now. You draw a triangle connecting the 2 points, okay? With arrows. If you don't have the points given, find 2 nice points on the line and mark them with dots. And that, what we mean by nice points is we actually call them lattice points. So you want a point where the line of your graph intersects with the grid lines so that you know exactly what the value is there. For example, I wouldn't want to pick this point right here because I don't know exactly what that is. So I'm not going to pick that point. Okay? And then you're going to count the rise, which is the up-down squares. And then you're going to count the run, which is the left-right squares. So the rise is positive. If it goes up, the rise is positive. If it goes down, the rise is negative. And for the run, if it goes to the right, it's positive, and if it goes to the left, it's negative. Okay? And then use the formula, which is that slope equals rise over run. Now I do want to show you one more thing that's not actually in your notes. If I had started counting from this point and then counted down, and I went 1, 2, 3, 4, 5, then my rise is actually -5 because it's going down, right? And then my run is 1, 2, 3, which is -3 because I was going backwards. So my slope is -5 over -3, which does equal 5 over 3. So I get the same thing. It doesn't matter which point I start at and where I end. I'll get the same answer. Okay, that's really important. And then when you're counting for a negative slope, one of the numbers will be negative. Okay, but it's always worth stopping and checking to see that your answer was right. That the sign that you get matches the sign you expect looking at the diagram. Okay, actually, here, let's just go back up here, because these questions you were just identifying them as positive or negative. So let's actually do the slope of, looking for what, this one, number C. Okay, so this is a negative slope, right? And if I count my slope from this point, this is a nice lattice point right here, and this here is a nice lattice point right there. So I can count my slope as my rise is 1, 2, 3, 4, 5, 6, 7. Rise over run, and my rise was -7, and my run was 1, 2, 3, 4, 5. My run is 5. So my slope is -7 over 5, which if I change that to a decimal is -1.4. Okay, but it is negative and that matches the graph. Okay? Okay, so go ahead and do the practice and then come back for the next lesson. All right, part D, let's take a look at horizontal and vertical lines. And we're going to calculate the slopes of the 2 lines on the graph. We're going to start with this one here, the one that goes across. This is a horizontal line. And you need to know what horizontal and vertical mean, okay? And if I do my slope from the 2 endpoints of this line, I get that slope is rise over run. And the rise from this endpoint to this endpoint is 0, right? It doesn't go up or down. And the run is 1, 2, 3, 4, 5, 6, 7. So 0 divided by 7 is 0. So my slope is 0. Okay? And then let's do this line, which is the vertical line. And if I try and calculate its slope, m equals rise over run, the rise from one point to another, I'll go from the bottom, 1, 2, 3, 4, 5, 6, 7. And the run is 0. There's no horizontal change for that. Now, what happens if you do 7 divided by 0? You can't divide by 0. Okay, so the answer here is the word undefined. That is the slope. It is undefined, okay? Because you can't divide by 0. All right, you just have to remember that that is undefined, okay? So horizontal lines which go like this, oops, always have a slope of 0. And vertical lines which go up and down always have a slope of undefined. Okay, and I do have a little trick to help you remember that if you want. You've heard the phrase wish upon a star. So we draw our little graph. Okay, so a slope, the line that goes straight up and down is the upon, so I'm going to write the upon. So the one that goes up and down is undefined. The one that slopes up is positive. One that goes right across is 0. And one that slopes down is negative. Okay, wish upon a star. Okay, go and do the practice and come back. Okay, here we are on page 25 of Workplace Math 11 graphing. We're at part E, graphing lines from 2 points. So this is really straightforward. You're given 2 points, you plot them on your paper, and you put a line through them both. Okay, so our first point here is at 5, 1. So that's got an x value of 5, 1, 2, 3, 4, 5, and a y value of 1. So that makes it this point right here. And the second point is 2, 4. So we're going to go 1, 2, and then up 4, 1, 2, 3, 4, which is right there. Okay, and then we're just going to put a line through them. So I'm going to, this takes a minute because this is not a great, it's not the easiest thing to use. A ruler is much easier, but doesn't work so well on the computer. So when you do your line, remember you need arrows on both ends of it, and you do want it to go more than just through the points. And accuracy matters, okay? So be careful about how you do it. All right, next example. We have a point of negative 2, 3. So this time our 2 is going to go, we're going to go backwards 2, starting at the origin, starting at the center, 0, 0. We're going to go backwards 2 and up 3, 1, 2, 3. So that's one point right here. And the second point is at negative 2, negative 5, which is down here. And we are again going to do our line. Oh, isn't that funny? Well, it doesn't want me to go straight up and down. Okay, there we go. Okay, so there's our line for that one. And for 3, we're going to go negative 1 and then positive 2. So that's that point right there. And then negative 4 and 0 is right there. Oh. And we'll draw our line. There we go. Oops, I spoke too soon. Okay, there we go. So go and do the practice work and then come on back. All right, we are now on page 26 and we're going to graph lines given the point and the slope. So on the graph to the right, we're going to draw a line, a solid line that passes through point A and has a slope of 6/5. So we're going to start at point A and we're going to count, remember the slope is rise over run. So this is rise over run. So our rise is +6 and our run is +5. So we're going to count up 6. 1, 2, 3, 4, 5, 6. And over 5, 1, 2, 3, 4, 5. And we're going to have a line that goes through those 2 points. There we go. There's our first line. Okay, and for B, we're going to do a dotted line that passes through point B and has a slope of -3/2. So remember that -3/2 is the same as -3/2, or it can be 3/2. If you put any of those three in your calculator, you're going to get the same answer. In this case, this is the one that makes the most sense to do because we can have a rise of -3 and a run of 2. So we'll do that starting at point A. So we have a rise of -3, 1, 2, 3, and a run of 2, 1, 2. And we put our second point here. And I will draw the line. Now I can't actually do dotted lines on this software, although I did figure out how to put the points where I want them to be, but I can make my line red. So let's do that. Okay, so that's the red line. Okay, go do the practice and then come on back. Okay, we're now on page 28, looking at using the point coordinates to calculate slope. Now, slope is calculated as the change in vertical distance divided by the change in horizontal distance, which we refer to as rise over run. If you're calculating the slope of a line going through 2 points, and you only have the 2 points coordinates, or the coordinates of the 2 points, you're going to use this formula. It's called the slope, or the slope formula, where point 1, it has 2 points x1, y1, and point 2 has the points x2, y2, and m equals y2 minus y1 over x2 minus x1. And the most important thing that you can do when you're doing these questions is actually write in above your numbers which one is x1 and which one is y1. So I'm going to call this as x1, y1, x2, y2. Now it doesn't matter which point is point 1 and which is point 2, you'll get the same answer, but do label them. It makes it so much easier and so much less likely to make mistakes. Okay, so our formula is m equals y2 minus y1 over x2 minus x1. So y2 is 6 minus my y1 is 2 over x2 is 5 minus my y1 is -4. Now, I did write in that as minus -4. If you try and change it in your head while you're doing it, it's just so easy to make a mistake doing that. So just don't. Okay, and then you'll want to rewrite this as 6 minus 2 over 5 plus 4, because of course a minus minus is a plus. So you end up with 4 over 9, and that is your slope for this one, 4 over 9. Write that a little bit better, 4 over 9. All right, second example. Same thing, I'm going to write in my x1, y1, x2, y2. Really, please just do that, okay? So m equals y2 minus y1 over x2 minus x1 is 3 minus negative 5 over 7 minus 5. This is 3 plus 5 over 7 minus 5 equals 8 over 2, which reduces to 4. All right, so the slope on that one is 4. Okay, go do the practice, check your answers, and we're getting to the end, so come on back for just a little bit more. Okay, we're now on page 29, and this time we are going to find a missing coordinate given the slope. So there's a little bit of algebra involved in this here. So we're going to use the same formula that slope is y2 minus y1 over x2 minus x1. So I'm going to label this as x1, y1, x2, y2. So our slope is 13 over 9, and that is going to be negative 4 minus 9 over u minus 6. Ooh, that's ugly, isn't it? Okay, so I'm going to clean that up a bit. 13 over 9 equals negative 4 minus 9 is negative 13 over u minus 6. And remember your good old cross multiply and divide. So I can cross multiply that and divide it by that. One really important thing to remember is that anytime you have something that's got two, like something with a minus or a plus, there are brackets around this. They're invisible. We don't bother writing them down, but they're there. So remember they're there, because that's really important. Now, what we're going to have is that u minus 6 equals 9 times negative 13 divided by 13. So u minus 6 equals, sorry, my page doesn't have that number here. 9 times negative 13 is 117. Oh, I guess I could just, if I put that in my calculator, that's negative 117 divided by 13. U minus 6 equals negative 9. And then I'm going to add 6 to both sides. Those cancel out. And I'm going to end up with u equals negative 3. And that's my value for u. Okay, let's do another example here. Slope equals y2 minus y1 over x2 minus x1, x1, y1, x2, y2, and the slope is 8. So 8 equals negative 6 minus 2 over 5 minus a. Now, before we can cross multiply and divide, remember you can write any number as over 1 and make that the fraction, okay? And then we're going to multiply. Oh, we should clean that up first. Oops. So what I have now is 8 over 1 equals negative 8 over 5 minus a. And then if I cross multiply and divide, I can multiply that, divide by that, and I get 5 minus a equals negative 8 divided by 8. So 5 minus a equals negative 1. And then I'm going to subtract 5 from both sides. And I have negative a equals negative 6, and that gets me that a equals 6, and that's my solution. Okay? Okay, go do the practice, and I will meet you on page 33. All right, this is page 33, working with slopes as a rate of change. If you travel in a car at a constant speed of 50 kilometers an hour for a length of time, you will have traveled 50 kilometers in 1 hour, 100 kilometers in 2 hours, 150 kilometers in 3 hours, and so on. If you travel at 75 kilometers an hour, you go 75 kilometers in 1 hour, 150 kilometers in 2 hours, and so on. You can plot these rates on a graph with time on the horizontal axis and distance on the vertical or y-axis, and you will get straight lines. And if you join any 2 points on the solid line and calculate the slope, it will always reduce to 50 over 1. And if you join 2 points on the dotted line, it will always reduce, the rise divided by the run will always reduce to 75 over 1. And the slope of this line is the rate at which you are traveling. It is the rate of change of distance relative to time, which conveniently is the two things that we've labeled the axis with. It's distance rise over run, distance over time. The relationship between distance and time for these two data sets can be written using these two equations. Oh, for the two graphs that are there. So the two equations, if we say that d equals distance and t equals time, then for equation 1, which I should probably label up on here. This is equation 1, the first one with the 50 kilometers an hour, and equation 2 is 75 kilometers an hour. So equation 1, distance equals 50 times time. And for equation 2, distance equals 75 times time. And this is the slope. And this is the slope. Okay, so the slope of your equation, of your graph, is your rate of change. Let's do an example. Willard works as an electrician's assistant and earns $12.25 per hour. Fill in the following table how much money Willard earns for working certain hours. Well, if he works 0 hours, he's probably going to make $0. If he works 1 hour, he's going to make $12.25. If he works 2 hours, he's going to make twice that, which is going to be $24.50. 3 hours is 3 times $12.25, which is $36.75. And then $49 and $61.25. Okay, and then we're going to graph that. So at one hour, we're not going to be able to graph it very precisely because of the graph that we're given, but that's okay. We'll do our best. So this first line is 10, halfway is going to be 15, 12.25 is going to be sort of halfway between those two. So that's the 1 hour mark. 2 hours, this is 40, this is 30, this is 25, or sorry, this is 30. 40, 20, 30, and 25 is going to be just a little bit below the halfway line there. 36.25 is going to be just a little over half. Oops. Sorry, the computer doesn't like dots or circles. 4 is $49, so just a hair below the 50 line. And 5 hours is just a little bit over the 60 line there. Okay, and then we can, we can draw our line through those points. Now this should be a perfectly straight line with all the dots on it, but sometimes we can't do a, oh, I did not a bad job. When the graph is like this, it's hard to do. It was hard to graph those points on the grid that we were given, but that's okay. What is the slope of this graph? So we're looking at question C. What is the slope of the graph and what does it represent? So M equals rise over run. And remember, I can take any points that I want. So I'm actually going to go from the 0, 0 to the 1, 12.25. So the rise here is 12.25. Notice that I'm not counting grids anymore, okay? On all of the graphs we've looked at prior to this, each grid was one jump, one number, one increment. Here, each grid is 10 on this side, and it's 1/2 on the time axis. So you have to pay attention to that now. So there's our slope, which reduces to 12.25, and it's dollars per hour, because this number on top is the rise unit, which is dollars, and this one is the run unit, which is hours. Okay, and what does this represent? This represents the hourly rate. Okay, and I would have got the same number if I had taken other points as well. Any 2 points, I would get the same answer. Write an equation to represent the graph. So I can say that the money equals 12.25 times the number of hours. How much will Willard earn in 50 hours? We're back to our good friend, the proportion. So I always like to put words out to the side of my my proportion. So I'm going to put words or symbols or something. So it's money per hour. That's the information I have. And I know that it is 12.25 for 1 hour. And we are asked how many dollars for 50 hours. And then we're going to cross multiply and divide. So x equals 50 times 12.25 divided by 1. So x equals $612.50. And I'm going to circle that so we can find the answer. Okay, question F. Or part F, if he earned $183.75 on a job, how many hours did he work? Well, we can use the same proportion. We've got our dollars per hour, and we know that the rate is $12.25 per hour for 1 hour, and the money this time was $183.75, and our time is our unknown. Same thing though, we're going to cross multiply and divide. X equals 1 times 183.75 divided by 12.25. Put that in the calculator, we get 15 hours as our result. All right, go and do the practice. We have one more mini lesson on page 36. You are almost finished Module 1. Example, Kyle timed himself jogging on a race course. He passed the 300-meter point 1.5 minutes after starting and the 5.6-meter point after 2.8 minutes. Show this on a graph. So on the bottom here, we've got time. And we're going to do this in minutes because that's the units that are used in the question. So this is 0, this is 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So each 3 ticks is 1 minute. So there's 2 minutes and 3 minutes. And it looks like, I'm not sure why this is like this, but that's okay. And each 2 lines is 120 meters. So after 1.5 minutes, which would be here, halfway between 1 and 2 minutes, he passed the 300-meter point, which would be right here. And at 2.8 minutes, he did the 560 meters. So let's see, between 480, each of these is 60 meters, so it's going to be just a little bit above this line, and 2.8 is going to be somewhere around here. Oops. Okay, and then we can do that graph. All right, and now I'm going to join those points, but this time I'm just going to join the points with a line segment without arrows on the end of it, and I'm not going to extend it past there because we only know what happened between those 2 times, so we can't extend our line past there or put the arrows there which tell us that it goes past there. All right, and then we want to figure out his average rate in meters per minute for this portion of the race. So this point up here, let's do this one first. The starting point was 1.5 and 300 meters. And this point up here is 2.8 minutes and 560 meters. And I'm going to call this, I'm actually going to write that over here because it's hard to read on the graph. So it's 1.5, 300. And I'm going to call that my x1, y1, and this is my x2, y2. And my slope is, oops, let me fix that for you, is y2 minus y1 over x2 minus x1, which is 560 minus 300 over 2.8 minus 1.5. This comes out to 260 over 1.3, which if I put that in my calculator, gets me 200 meters per minute. All right, that is the end of the notes for this unit, but you've got some more practice to do, so go do the practice, mark your work, and then go and do the quizzes. Good luck.